Welcome, ladies and gentlemen. We are going to be talking today about experimental design. How do we design an experiment properly? Okay, so first, the scientific method is a really important thing to know, and you've heard this before. These are the steps that I usually ascribe by, and everybody's a little different, but these are the steps that I'm going to hold you accountable for. So first of all, we ask or state a question. I'm going to turn my face off because I know that something's going to come up. Thank you. We ask or state a question. We make a question first. Then after we've asked or stated a question, we then do observations and do some research and make observations and do the things that we need to do. Okay? Then next, we are going to form a hypothesis. As we're forming a hypothesis, but before we do that, we have to choose our variables first. So after we make some observation, we're going to list the variables, and then we're going to choose the ones that are independent, dependent, and constants before we write the hypothesis, because the hypothesis includes those pieces of information. After we've formed a hypothesis, we're going to test that hypothesis by doing an experiment. After experimenting, we're going to analyze the data. We're going to graph it. We're going to do calculations, whatever it takes to analyze that data. Then we're going to retest the hypothesis if we need to. If our results are not the same, we're going to go back and we're going to reform a hypothesis and begin the process again if our retesting doesn't produce results. But if we get the same results from our hypothesis, because we need to test more than once to make sure that we're doing the right thing, we're going to draw conclusions. So this loop in the center here, this loop right here, is really important because this is where we make decisions about what we're supposed to be doing. When we retest the hypothesis and we get good results, the same results, we draw conclusions. If we don't get the same results, we go back and we reform hypotheses, test them again, retest, and then go through the procedure again. So this is what most people would consider the scientific method, and most people have similar viewpoints here. Observations. Well, observations that we make in the very beginning are simply that. They're observations. We use our five senses to experience them. If we can see them, hear them, smell them, taste them, or touch them, we consider them observations. But we have to be really, really careful that we don't make conclusions. That means we don't infer outcomes. For example, it looks like it is going to rain. Just because we see a rain cloud or what looks like a rain cloud doesn't mean that it's going to rain. And because we infer that it's going to rain, we make that a conclusion instead of an observation. If we say it looks like a rain cloud, that's an observation. So oil has black flecks in it. The oil needs to be changed, okay? So the first one is an observation. The second one is a conclusion. The fruit has a bad odor. The fruit is rotten. The first one is an observation. The second one is a conclusion. Second part to observations, we can have observations that are quantitative, and quantitative observations are those that have been measured and must have a number and a unit. Qualitative observations are observations that tell us a quality, what something looks like, the color, the odor, the feel, the sound. So anything that's not been measured is called a qualitative observation. So let's look at our list. The car is 2,500 kilograms. That's quantitative because it has a measurement in it. The car is silver. That's qualitative because it's giving me a color or a quality. The temperature is 37 degrees Celsius outside. That is a quantitative. It's got a measurement in it. We can read that. It's hot outside. That's a quality. It's hot is the quality, but it's not a measurement. Okay? So what is an independent variable? An independent variable is simply this. It is the variable that is changed on purpose. So it is the one that I am choosing to change. I am making the change. I am choosing to make that change. So it is my independent variable. Only one variable can be changed at a time, so we can't have more than one independent variable. We can only have one at a time. If we need to test more than one independent variable, we test the first one, find the results. Then we test the second one, find the results. If we test them together, we don't know which one produced the results. We have to test them separately to get that. A question to ask yourself when you're trying to figure out what an independent variable is what is being changed on purpose in the experiment? So when you read experimental designs, the one that is being changed on purpose is the one that is the independent variable, the one that the experimenter chose to change. Choices of IV. Now this is where I get into a little bit of a problem. Or we also call them levels of IV, choices or levels of IV. And what we're talking about is, what are we choosing to be that part of that variable that changes? So for example, some of you will see today, we're going to be choosing the wick only, the wax only, and the whack and the wick together as our candle materials. Our candle materials are the independent variable, the thing that we're choosing to change. The level of candle material are just the wick, just the wax, and both of them together. So they are the different choices that we're testing. If we were testing, let's say, the amount of sugar in juices, well, the different kind of juices would be the things that we're testing. So, Snapple, I can't remember the juice names, like Capri Sun, whatever we're testing, those would be the different things. I'm sorry, I'm having a hard time getting one out. So dependent variables, the DV. The definition for dependent variable is the variable that is used to measure the change expected. So we have to measure something. So this one has to be measured. It has to have a unit. It has to have something that we can do. Sometimes we measure a quality, a color change. So question to ask, what is being measured in the experiment? We can actually have more than one dependent variable. So we could measure the pH and also observe a quality change. So that would be an example where we might have two DVs that give us a ways to look at things a little differently. Okay? Constants. Now this is the one that everybody always knows. This is the one that everybody's like, oh yeah, they're the ones that stay the same. We know what a constant is. So only one variable should change at a time. So any other variable that's in the experiment has to be constant. So you have one that is changed on purpose, one that is being measured, and everything else has to remain constant. It cannot change. So question to ask would be, what variables are remaining the same in the experiment? Now, the next one is control group. Control group is a really hard thing sometimes in chemistry class, but control group is the thing that represents the normal conditions. What is normal for an experiment? For example, if we're growing plants, normal would be the amount of water that they get. They have to get the water that they need. They have to get the sunlight that they need. That would be normal. Varying from normal is the test that we do, but we choose the one that is under normal conditions to be our control group. If we were trying to figure out if a plant would grow without soil, well, plants usually grow in soil. So that would be the control group, the normal conditions. So anything that's normal. In chemistry, sometimes we have a hard time determining control group, but remember the words, it's normal. What is normal to happen? So question to ask, which group recreates real life condition, or the normalcy, the regular conditions? So how do we put this together? Well, after we've chosen all our variables and we've defined IV, DV, and constants, we can now choose a hypothesis. A hypothesis is what we call an educated guess or prediction of an outcome. It has to be educated because we need to have done some research so that we know or think that we know what's happened. So the format that we want to use is something called an if-then statement. The if part of the statement talks about the independent variable. If I choose only the wick, I make a choice of one of my IV choices, and I list that down. The then part is what I expect to see from my DV. So if I choose only the wick, then it will burn for the longest. So I make a qualification. So the if-then statement is required to help us get there. Most of us have a really hard time creating hypotheses that are correct, that have both the IV and the DV in it. So I'm going to force you right now to use this if-then statement so that you're getting the IV and the DV in there. It may seem simplistic, but right now we need simplicity because we have to figure out how to make sure we write proper hypotheses. So experimental design is this. We need to ask some questions. The first question we ask, what will we purposely change or control? Once we figure out that, we know our independent variable. The next question we ask is, how will we measure the change that occurs? So once we ask that, we know our dependent variable. And then finally, what will we keep the same? The things that we will keep the same end up being our constants. So once we've asked those questions, we have the ability to then write a hypothesis, write out a procedure for an experiment, and conduct that experiment. And we're going to be doing some of that tomorrow. Now, I'm going to introduce one more thing because we're also going to be seeing this tomorrow at the beginning of our activity. So this is called the experimental design diagram. And as you can see, this is a diagram that simply organizes all of the things that we just talked about. You can see that we have our IV. What is our independent variable? Then the choices of IV. What things are we choosing to change? How many trials are being done? So all of the top 3 are part of your IV discussion. DV. Define what the DV is. What are you measuring? You write it down right there. What things are you keeping constant? So anything keeps constant is written here. Control group. Which one of these choices of IV represents normal? And then finally, a place for you to write your hypothesis, an if-then statement. Now, title we're going to talk about a little bit later, but titles also have to have an IV-DV component. You have to be talking about, you can't use a question. It has to be a statement, and it has to have an IV-DV relationship, and we'll be talking a little bit more about that later. But titles are important, and they're similar to hypotheses without being questions, and they're not exactly hypothesis statements. So for example, for our experiment that we're going to finish conducting tomorrow, we might say something about the effect of changing the candle material on the time of burning. So yes, it's long. Yes, it's not cute, but it's not meant to be cute. The title is the first line of defense. As we're reading through papers, the title is what catches us. If the title doesn't include enough information to catch us, we discard that piece of information. So we want titles that are appropriate, that tell us the IV and the DV, and tell us how we're expecting the relationship to occur. What are we trying to find out? How the candle material affects the time of burning. That's what we're going to be trying to find out. So hopefully you've learned some stuff and you'll be prepared for tomorrow. Thank you very much.